Hi, good morning, good afternoon, good evening. I guess we can get started. We have some exciting news to share, and we are still going through all this COVID situation here, and we really appreciate that you have joined to listen to our webinar series for 2021. So, with our kickoff webinar this year, we are announcing our cloud application resilience availability on Azure. We have had successful launches and several customers signing up and using in production on AWS and GCP, as well as our other environments, including container-based applications. We thought of bringing the same or more capabilities on Azure. So with that, let's get started with our webinar. In this one, we'll talk about securing and protecting the entire application environment for Azure well-architected framework. We'll go through what those pillars of the architecture framework are, as well as go through a detailed demo in terms of understanding how a distributed application can be protected using Appranix and replicated to another region to bring up the application resiliency for the entire application environment. This webinar will be recorded and distributed on the YouTube. So if you could share this webinar with your other colleagues or across your social media, Appranix team really appreciates the effort. Thank you. So with that, Appranix is a Gartner cool vendor on cloud application resilience. We are pushing the boundaries of the traditional backup and recovery area where there has been a lack of innovation, so to speak, beyond just protecting the virtual machines and databases and so on. That's why we have come up with the capability to protect the entire application environment. We call it as cloud application resilience. With that, if you think about the Azure well architecture framework or the pillars of that framework, it has 5 pillars within the framework. One is clearly the operational excellence, where you will have to really think about architecting your application infrastructure with probably CI/CD approaches, including creating the tool set around the DevOps so that you can release your applications faster and quicker in terms of protecting as well as monitoring the applications, as well as really driving that speed of innovation to the next level using all the cloud services that are available on Azure. Second, but the most important one that we will go deeper into is the reliability pillar, where the backup and disaster recovery or even chaos engineering, if you are willing to push the boundaries in terms of testing the resilience of the system while running in production itself. So there are a bunch of best practices explained in a lot of documents within Azure documentation area, where you can find a ton of information on well architecture for reliability. Third is the security. Everyone at the time, going back 5 years ago, when people thought going to the cloud was a security issue, and it's not the case anymore. In fact, cloud has become a lot more secure environment, and the combinations of software-defined infrastructure and the protection mechanism available on the cloud is second to none at the moment. So there are a bunch of best practices around security and best practices around cost optimization in terms of how you could minimize the bill shock, if you will, if you could optimize around the services that you really need and other services that you could turn off and things like that. We are not going to go into cost optimization or security issues of the well architecture pillars. Performance efficiency also touches on the reliability part a little bit, especially with respect to operating only the infrastructure that you need, and the ability to automatically scale that infrastructure, right, based on the application needs, so that you don't have to manually go and provision the infrastructure every time. That is where the services like resource group oriented approaches are coming in, and how you could easily optimize the performance of your application by scaling up. I would call it scale out, and when you don't need it, scale back in. But in those situations, how the reliability of the application itself will be taken care of. So in the cases where if you're adding more and more virtual machines based on the workloads that are experienced by the load balancers that are front-ending your applications, then what happens to your backup and recovery, and in particular, how does the disaster recovery itself will behave when you fail over to another region of the cloud. So we'll go into these three aspects. One is the operational excellence pillar, where we can show you the capabilities of rehearsing the recoveries and practicing the failure, how you can recover from the failures and so on. Second one is the reliability pillar, and third one is the performance efficiency pillar, clearly. Given that, when you create the applications directly on the cloud platform using all the services that are available, or when you moved your application from the data center over to the Microsoft Azure, the important thing that you'll have to ask is, are your applications really resilient? The reason for that important question is that when you are operating, let's say in the data center, you have customized your application infrastructure to suit your needs of the platforms and the tool set around that particular application in the data center have been customized over a period of time. So you don't really really think about adding more applications and so on. But when it comes down to the cloud infrastructure is shared, so which means that you share the responsibility with the cloud provider. The cloud provider takes care of the resiliency and the scalability of the infrastructure as a service, and also providing some of the core capabilities to, for example, make snapshots and make sure that you could have enough replication capacity to replicate your environment to another region and so on, or providing the necessary infrastructure as code so that you can achieve a desired state for your application infrastructure, right? And also when you're thinking of microservicing your application components into container-based infrastructure, then now you're operating more and more containers for your microservices, which means that you are distributing your application configurations, application infrastructure a lot more than what it used to be before. In that case, what is the resiliency for your application? Let's take a simple, multi-tier application. It's not like two-tier anymore. It's not even three-tier anymore. It's a multi-tier based application. In the multi-tier based application, if you think about a typical Azure multi-tier application, has a web tier where you have a load balancer that is distributing your web tier components across, maybe one zone, maybe multiple zones. And there is a business tier where you could have another load balancer that distributes your business tier infrastructure, across a single zone or multiple zones. Similarly, the data tier as well. So all these three layers now can independently scale, and then you might have another load balancer, front-end load balancer, before reaching out to the users or reaching through another means, through an internal network that is preventable from a security perspective or not. But the important components of your applications are the web tier, business tier, and data tier in simplistic terms, if you have to think about it. Even with this configuration, the application, the complexity has grown compared to what you might have seen before, which means that if you have to really think about backup and recovery in that environment, that the notion of backup and recovery is almost like an infrastructure level speak. The nomenclature has changed, what if you could think your backup and recovery as well as disaster recovery, overall the resiliency of your application from an application-centered perspective, right? If you start from your application and look down your infrastructure as opposed to looking at your infrastructure and looking up to your application components and trying to protect all the components of the application, right? That's the difference between the traditional, what we call a legacy backup and recovery approach and an application resilience approach, where you start looking from top down, look at your application components, look at what really makes up that application components with respect to not only just the virtual machine or container-based infrastructure and the storage infrastructure and the network infrastructure, but other layers of that infrastructure as well, right? And that's when you start thinking about how to really protect your applications properly. The applications could come down, could be disrupted for many reasons. It could be as simple as a bad deployment, right? When you have infrastructure as code, you are configuring something in your infrastructure as code and through your CI/CD platform. At the same time, some other developer or an SRE is trying to deploy another configuration of another component of your application. It could bring down your application itself. Or it could be because of a ransomware attack, right? The ransomware typically nowadays are very, very sophisticated. They are just dormant for a while, could be weeks, months, and maybe years. And after a while, they are activated, which could completely compromise your entire application environment or all of your application tenant or subscription itself, for that matter. In that case, even if you are willing to pay for the ransoms, let's say you paid for it, you are able to get the application access back, but now how do you really recover your application infrastructure properly, right? It's not about getting the keys for your databases, right? That is one of the component, one of the activities that you might end up doing. But what about your application infrastructure itself? Can you make sure that you are now protected properly? What if you had a capability to really bring up that environment as of last week, so that you're at least borrowing some time to analyze what's going on in your environment? What happens when you have a cloud zone failing? Or could the zone failures and region failures are expected when you're operating on the cloud platform. Region failures may not happen all the time unless there is some kind of a natural disaster or a specific set of problems. Region failures may not happen all the time, but zone failures might happen, which means that you will have to really architect your application based on, again, Azure well-architected framework, so that your applications are properly distributed across different zones. Or otherwise, we'll have to really think about protecting that your application environment against zone failures. And there are other reasons why an application could fail. On an average, what Gartner estimates is that it could be 300K per hour. It could be more, could be less. On an average, it's about 300K per hour, or $5,600 per minute, depending on the criticality of your application. You might think about the cost of really creating that resilience. Now, the solutions are there. Solutions have been around. Solutions have been around in terms of, again, looking at an operational excellence pillar alone. You could potentially monitor and then add some fixes manually, or you might have some automated approaches to fixing a set of problems. But there are other ways of recovering. The backup and recovery systems have always helped in terms of bringing up a subsection of your infrastructure, right? All these backup and recovery capabilities already existed in the data center. These legacy providers, what they have done is that they have started supporting the cloud applications now. Totally fine. That is one way to do it. But the issue is not about looking at that infrastructure from compute-only perspective. Even with compute, now you're talking about just recovering the virtual machines, whereas the legacy backup and recovery systems cannot recover all your dynamic cloud resources. We'll go deeper into what those dynamic cloud resources are. Just think about load balancer as an example. Second, you'll have to really think about protecting your infrastructure with the data management lock-in. So if you think about legacy backup and recovery approaches, you will have to typically put an agent on every virtual machine, or even if you have to really protect at the storage level, you'll have to think about moving all the data to another data management system, a proprietary data management system that locks your data. Not only taking time to pull the data from your production infrastructure over to the data management system and delaying all your protection capabilities, right? RPO goes down because you're pulling the data again and again. Third important thing to note is that all your resource dependencies for your application, distributed application. Now the applications are not simpler anymore. Applications are becoming complex every day. If that's the case, what's your dependency between application components? What's the dependency between your load balancer and your set of virtual machines on the web tier, and the set of virtual machines on the business tier, and the set of virtual machines on the database tier? Again, to think in terms of just three-tier application architecture. What are the configurations for those infrastructure? So what's happening now is that the customers that have moved to the cloud, they have realized that maybe another way to look at this is to make use of existing infrastructure capabilities that are provided by the cloud platforms themselves. Snapshots are there. There are capabilities in the API that are exposed by the cloud providers, where you could pretty much schedule the snapshots to protect so-called, it's a compliance issue to start with. So you could start protecting your environments. Absolutely. But the issue is that, let's take a simpler case where you want to do 1 hour snapshots for your 500 virtual machine environment with 2, managed disks on the Azure side with 1 day retention. All you are protecting is that every hour you're protecting with snapshots and you are retaining for 1 day. Right? With 500 VMs, 2 disks, you are talking about 24,000 snapshots in a single day. Just imagine that. You go into Azure console and you look at these 24,000 snapshots, and how do you really recover your application components? Is it going to be web tier? Are you tagging the infrastructure properly? Even if you tag, how do you really plan to recover that infrastructure? That's where we looked at the entire problem. That's where we come in and say that probably a different way to look at the entire problem. Isn't it easier to look at from an application perspective down to the infrastructure and see if you could protect every component of that application infrastructure? It's not going to be expensive. It's going to be, one time full and then every time incremental forever. If that's the case, can you look at an opportunity to replace your backup and restore approaches that you might have gotten used to, or even the replication that you might have put together at the host level or at the virtualization infrastructure level with an agent that copies all the virtual machine from one data center to another data center, or container-based applications where all the containers that are dynamically moved by Kubernetes, right, between nodes using your pods. Your pods can run multiple containers in a single pod. And now you'll have to protect what the containers are. Do you want to protect your pods? What if the pods are evacuating all your containers to another node? So how do you really protect them? And the situations where you want to protect your application from bad deployment. Again, a customer case study exists where they protected the application environment with storage level snapshots really quick, so that if there was a bad deployment, you could at least have a mechanism to revert back all your virtual machines to an earlier point in time. That's an approach. Or site recovery, where you assume that you have entire application environment failed, entire site failed. Now you can bring up the entire environment to another region of the cloud. So we looked at all these problems together. We came up with a solution, very integrated, a single approach to managing the entire application environment. We call it as application resilience, right? Where you can protect all your application environment resources and the dependencies, and simply add the policies, based on your enterprise requirements. It could be 1 hour policy, it could be a daily policy, it could be a weekly policy, again, different retention, monthly, yearly, and so on. So when you have, look at that, this is where I don't like the systems automatically taking over. So anyway, with Appranix, there are only 3 steps. You subscribe and you add the policies and the entire environment protected, then you just go ahead and recover whatever you want in terms of your entire application environment in another region of the cloud, or just individual resources in your local region that will satisfy your regular backup and restore requirements, or your entire disaster recovery, where you want to recover multiple application environments together in another region of the cloud. All of that use cases will be automatically covered, and we can do it, over a coffee break. I mean, we have done this many, many times over. So what we do, if you drill one level deeper into, what our platform actually does is it reverse engineers your application environments without modifying any of your production setup. It's read-only access. You are pretty much, allowing access to, read the metadata of your environment, looking at, for example, the size of the virtual machine, because regular backup and recovery systems never cared about the size of the virtual machine. They all left that smaller issue to the customer. Customer has to figure out what is the size of the virtual machine so that I can recover my file system. So what Appranix does is it automatically discovers all the metadata. It automatically discovers all the dependencies between the resources in your cloud environment. Automatically takes care of the lifecycle management for your the backup for all your configurations, all your metadata, all your virtual machines, and controls the data lifecycle for your application. Protects all your load balancers, security groups, gateways, and so on. Again, we can do it without any agents getting installed in any of the virtual machines. No agent architecture. And that's where you start thinking, so there is definitely a better approach on the cloud compared to what you might have gotten used to before. And all of that comes with an application environment time machine, which means that Appranix automatically creates that application environment time machine. And using the time machine, you could go and recover your application environment at any point in time. So you could go and recover the latest if you are really kind of, messed up your application deployment 15 minutes ago. Or you could go back a week ago and say, oh, I can recover this particular environment at that particular configuration and the state so that you can recover for different purposes. For example, you could use it for performance tests and so on. So in simple terms, when you think about how you can do it compared to the legacy backup and recovery, is that typically, you create your application environment, right? And you create the network. You make sure that the production environment configurations are retained when you recover your you recover your application at the recovery site. All of that you'll have to pre-create, and then you recover your individual virtual machines or a group of virtual machines using the legacy systems. Instead, what Appranix does is it automatically creates the entire network, entire security groups, entire load balancer configurations, a new instance of load balancer configuration, and all the virtual machine at a particular point in time. Again, indirectly, we leverage all the built-in Azure capabilities. So the performance, the effectiveness of the recovery is much faster compared to what you might have gotten used to before. And that is what we call as application resilience. And of course, customers use it for many other purposes, not only for regular backup and restore or a disaster recovery. People are syncing between 2 different regions, or you can recover for, from a ransomware attack, or you can clone the environment for application testing purposes and leave it running for a couple of hours or a day or so. And once the performance test is complete, you can get rid of that environment easily. If you want to stretch beyond that, you can also embed application resilience into your CI/CD pipeline. what we call that as in continuous resilience. You can achieve continuous resilience along with continuous integration and continuous deployment as well, with one line of code. We don't want to get into pricing itself, but just to give you an idea, it's very, very straightforward in terms of pricing. And, all you pay is a per instance per month, right? And then your cloud infrastructure is gone. You don't have to pay anything else. In terms of counting the number of instances, our system automatically discovers all the instances, so you know exactly what you're paying for. Within about 15-20 minutes, you will know exactly what is the cost of your protection for the entire application environment. A number of customers have used the system. One of the highlighted one is the CTO of LoadSpring said it's a game changer service. There are a number of reviews on the G2 review board as well. The latest one is you have to try out Appranix. It's so simple to use. So please go and check it out. Financial services companies have used our system. This particular enterprise company running 3,000 plus resources, and they have done $15 billion mortgage applications last quarter alone, and they have done so far 4 DR tests within the last 3 months. Every DR test took 48 hours for them. A test took 48 hours with all their teams working together over the weekend, and costing about 30 to 40K per test. That's no more. They are able to do these tests more and more. They tried over the weekends, then now they are trying on a Monday. Right? Can you imagine that? Doing a DR test on a Monday. Of all the times they have chosen to do a DR test on a Monday. So people are getting comfortable doing the DR test more and more, recoveries more and more, and now it is possible on the cloud platforms. So with that, let's jump on to the demo itself. That way, you get to see the power of the platform, and then let's answer some of the questions that you might have on the board. So to start with, let's go into Azure. If you look at Azure console, it's a typical console. I have not complicated this demo environment. There are a bunch of resource groups, and if you look at the resource group itself, the way Azure has architected, it's really nice. They have, if you look at again the well-architected pillars, if you think about the operational excellence part of it, it's about grouping your resources properly, and they're nicely named as resource groups. So in this particular case, we are running an application called OpenEMR. OpenEMR is an open emergency medical records application. It's a well-known system used by many hospitals as well as smaller clinics and so on. And for that, I've just populated one particular area, and you have many different boards, messages, patients, fees, modules, and so on. So you have different boards here. Patients are the most important ones, so I simply brought up that particular scheme. And also you will see when the environment goes down, this is running on the central region at this particular IP behind a load balancer. This is the load balancer IP I will show you. And what we will do is that we'll recover the entire environment, including all the data, including all the patients and records and everything in another region, in this particular case on the East Coast. So if you look at the resources themselves, if you look at the OpenEMR resources, we are running multiple resource groups. OpenEMR is a resource group in the central region. So if you look at that resource group, you have a number of resources, right? You have the security groups, you have the load balancer. If you look at the load balancer here, it has multiple configurations, right? And if you look at the VNet itself, it has a bunch of configurations here. It's not just the infrastructure that people have gotten used to in their data center, or even the newer infrastructure like Kubernetes. It's becoming a lot more distributed and a lot more dynamic, so to think of the application infrastructure itself. So if you look at a security group has multiple configurations and the ports that are allowed, the protocols that are supported for an application of, it's a modest application. It's not too complicated. It's about 6 VM configuration here, and 2 VMs on the web tier, 2 VMs on the DB tier, and 2 VMs on the platform tier, right? And if you look at the VNet configuration itself, it's a configuration that has a bunch of scale sets. So if you look at the scale set, within the scale set, you have a number of VMs that are running, and then VMs have configurations of their own. So if you look at the configurations, including the manageability of the VM itself, you'll have to preserve the manageability so that when you bring up that environment in another region of the cloud, right, you should be able to manage. Otherwise, what's the point of bringing up the entire environment? What about the tags for those resources, right? You should be able to bring up the tags. Otherwise, it's very difficult to really operate the application environment. So it is not just bringing up a bunch of virtual machines or the databases. We can all assume that you can bring up those infrastructure, but what about your application? So the way that we looked at is that starting from an application, let's say an open EMR, right? And if that application goes down, right, we'll simulate that application configuration here. When that application goes down, how do you really plan to bring that up? Right? So, this application run, as I mentioned here, on the central region of the cloud. So you can see the central region. And if you go to the east region, when you search for resource group on the East Coast, EMR doesn't exist. That's the idea. We will bring up that EMR. That is a bunch of resource group, but you don't see any open EMR. So let's filter it up. We call it as EMR, and let's see how we can bring up the entire application environment if the central region environment goes down. So if you think about it, let's bring up a resource group. We can simply kill this application. You can take down an application virtual machine set here and say stop the entire set, right? When you stop this entire application set, all the virtual machines underneath will go down, so which means that if I refreshed it, the application will not come up. So you can see it's connecting. Chrome takes a while to make sure that the application, so the application is now down. Now we have to really bring up this application. This is the complexity. This is where Appranix comes in. The way to protect your application starts with making a cloud connection, right? The cloud connection, there are multiple connections here. So you make a cloud connection, you go and select Azure. We can simply execute an ARM template to allow read-only connection into your environment. So you make a connection, and if you go into the cloud connection, we already made a connection for demo purposes. So if you look at a cloud connection, it's simply compute, and the compute involves all of the infrastructure running on the compute and the load balancer. If you think about it, all the resources are automatically discovered. There are 32 resources for the open EMR. All those resources are automatically discovered. If you look at the load balancer, load balances, the subnets, the scale sets, with the entire virtual network, and the resource groups as well. So all of that will be automatically discovered and kept in sync all the time based on your policies. So after making a cloud connections into your environment, you simply create something called a cloud assembly. Cloud assembly is nothing but an assembly of your resources. It's not too complex to think about cloud assembly, as it's as simple as bunch of virtual machines or bunch of your nodes. So if you think about it, the virtual machines, in this particular case, a virtual machine set and the load balancer set, these all basically the initial ones. And it's based on the virtual machine set. You can see that virtual machine, the front end is already gone, right? We automatically discover, so the web tier is already gone. So if you think about it, the policy that we added, an hourly policy, automatically protect that environment. That environment is protected in our application time machine. We call it as an application environment time machine. That's because based on the policies, an hourly policy or daily policy, weekly policy, and so on, the entire environment is protected, right? So if you think about it, an hour ago, in fact, it's 3 hours ago in this particular case, I'm looking at a 3 hour ago protection. All these application environments are properly protected at that particular point in time. It's, it took about 17 minutes to protect the entire environment. Again, it varies depending on the application types and so on. Now that the application is down, let's bring up that application as of, let's say, pick middle, right? And all we have to do is to go and recover that particular application environment. We call it open EMR. So call it as open EMR recovery. And select the other region, in this particular case, East Coast, and we select entire assembly, or if you want to do a typical recovery, you can do selector resources as well. Entire assembly, say hit recovery, and simply say recover. You can also enable automatic reset, so you don't have to remember to delete the environment after doing a DR test, as an example. All you do is just enable that. For demo purpose, I'm going to turn it off so that I can delete manually as well. Recover it, hit the recovery button, right? That is all you do. So if you look at the recoveries, it starts with the load balancer, which recovery system starts with a load balancer to begin with, right? And the security group and the scale set, the virtual network. These are all the things that you will have to manually do ahead of time to bring up your application environment, even if you had the capabilities to recover from your snapshots or recover from your backup and recovery system, backup and resource systems in the local environment, or do a DR to another region of the cloud itself. It takes to lay down that infrastructure. If you already lay down the infrastructure, you just go ahead and recover one resource. That's totally fine. But if you have the entire environment gutted, right? Entire environment was affected by a ransomware attack. And that's when it really hits to see that, you're now under panic. You have to bring up that environment really, really quickly without really understanding all the configurations of your environment. So if you go into your environment here, you will have to really understand all the configurations of a load balancer, right? All the configurations of your, let's say the database that you're running on a virtual machine, right? All the configurations. What is the size of the RAM, size of the CPU? Otherwise, your application will not come up because you're undersizing, or maybe oversizing is okay, but you're if you're undersized for cost reasons, then your application is not going to come up, right? And again, multiple application layers. This is a very simple one, but if you complicated it, now you are responsible for bringing that entire application environment up so that your application can run in another region of the cloud. And that is when you realize that you need a system like Appranix, where you could bring up the entire environment, and you can look at the resource group here. If you look at the resource group, if you look at the application configuration, all the virtual machines, again, you are running, just to make sure that you differentiate between, you can see the differentiation between what was shown and what is running here. The location that we said, let's go back and look at all the resource groups and filter out the resource group for the East Coast, because that's where we brought up that environment. And then filter out the EMR alone, right? Previously, when we filtered out, there was no EMR. If you look at the central region already has an EMR running. We just turned off the front end of the open EMR application, right? And if you look at the resource group for the central region, location, central, right? And then EMR here, open EMR, right? I don't know why it goes back to the central. I think it is, I'm using the same session here with same login. So even though if I switch, it kind of misbehaves. So in the central region, you have open EMR, and that open EMR was brought down with a simple attack simulation, let's say. And on the East Coast, we have the entire application environment brought up, right? And this is where when Appranix differs. You can see the network security groups, the IP addresses, the load balancers, the virtual machine sets, virtual network itself. So if you look at the virtual network, entire virtual network was brought up between the application components and the database components, right? The scale set of the instances were brought up. And that's where, the difference between an application recovery system, we call it application resilience, that you provide using our system, as opposed to a simple backup and recovery system. So if you look at the environment here, let's cut and paste that IP alone. So let's take that. Let's see if the application is back up and running. There you go. The application is now running. This is still struggling. You can see the front end is still struggling. Let's stop that. So the application is now back. I typically forget the password here, so let's. If you log in, the application should bring back all the patients as well. There you go. All the patients are back, right? It's as if nothing happened, right? Your application is back. And again, the only thing that you did, right? Only thing that you did was to hit that recovery button. Everything else was automatically taken care of, right? The magic obviously happened using all kinds of capabilities of the system. As I mentioned before, indirectly, Appranix takes care of all the complexities of, recreating that environment. So Appranix automatically created the entire infrastructure as code, native infrastructure as code, the ARM templates. And if you look at it, the system automatically wrote this many lines of code, using the capabilities that are already built into Azure. If you look at graphically what was brought up, you can see all these configurations, all the dependencies between the resources have been automatically created, right? Then display different layouts here. So the dependencies, the configurations, and the sizes of the system themselves, all of that are automatically taken care of. All you had to do was to hit that button once, right? And once you're done with the system recovery, you can pretty much remove it with another button. So you simply say delete. All the recovered resources will be automatically deleted as well. So as simple as that, right? I don't think we can simplify beyond this. And achieving application resiliency is not hard, right? Maybe backup and recovery is hard, right? But even if you protected those resources, how do you really bring back those resources? How do you really connect those resources together with the dependency? How do you really make sure that the configurations are proper, right? So that your applications run. And that's where we say, the difference between, typical backup and recovery system and a system like application resilience, right? It's that simple. You bring up an application environment, you create the network, you bring up all the virtual machines, the sizes of the virtual machine, and then you attach the disks or the images back into those virtual machines so that your applications will come up. None of that, because we are completely leveraging Azure capabilities, including making sure that the snapshots are captured, application consistent level, replicated to regions that are not even supported by Azure Site Recovery. Right? If you think about Azure Site Recovery, you can protect using Azure Site Recovery in another region, but you can protect only the virtual machines that are capable of replicating from one region to another region, paired regions. So Azure has the concept of pairing the regions, maybe because the data centers are available with the right throughput and so on. But Appranix can actually for example, protect your environment in Singapore and recover that same application environment in India, for example. I'm just throwing two different, completely different countries to give you an example, whereas ASR cannot do that. And it's not like you have to get rid of the Azure backup. Internally, we use all the Azure backup capabilities, all the capabilities for backing up your environment, backing up your virtual, backing up your containers are properly leveraged using Azure capabilities, right? Which means that, if you're using Azure backup or Azure site recovery, you can pretty much switch over to Appranix, and you might end up actually paying less, right? Sometimes to have the application environment recovery completely by leveraging all the capabilities slightly differently, right? And all these cloud providers will catch up at some point in time, but currently, the application resilience is now possible with Appranix. Anyway, let me stop here and see if there are questions to be answered. Again, the entire webinar will be available on the YouTube. You can, reach out to us anytime. We'll be able to provide a dedicated demo as well for your environment, or we could even just quickly onboard your dev environment to start with. Some customers have, after initial testing, they have within 15 minutes they onboard their production environment as well. So we are flexible in terms of allowing you to quickly test the entire setup. We'll also give you free 15-day trials so that you can go through your application resiliency, test it out at no cost. So, and you can really onboard the entire environment afterwards as well. All right, if there are no questions here. Oh, there are questions. Yep. Mike. Okay. If there are no questions, let's call it a day. We'll give you a few minutes back, your time as well. And we are here to help in terms of protecting your application environments on Azure. Thank you. Really appreciate the time. Have a great day.